Boom. Hello and welcome back to Differential Equations, section 1.5, linear first order equations. Linear, we said no square on the derivative. It's not sine of y prime, stuff like that, right? So it's linear. First order means only the first derivative. And all of these equations can be represented in the form dy dx plus p of x y is equal to some q of x. So this is the form of the first order linear differential equation. Clearly the solution to this is a function, and everything depends on these functions p of x and q of x. Now, the method to solve these equations, well, we know that we can do the slope field and all that stuff. Hopefully you see that separation of variables doesn't work here, because you cannot separate y from x. In a lot of cases. So what we do is we realize that we have a function and its derivative over here. Now, if you recall the product rule formula from Calculus 1, we know that the derivative of f times g was fg prime plus gf prime. Observe that you have the same behavior, that you have a derivative and a function, which means that this p of x is this f prime. Do you see that connection? So, well, sorry, it's this p of x, it's not f prime, it's close to it. So if I multiply this with some, well, they have a different letter. I use mu. I believe that book uses mu. They have rho, so we'll use rho. But if you multiply this with some function, then that function could play the role of the function, and the multiplication of these two could play the role of the derivative of that function, and you would have a product rule on this side, which you can condense into this, and this can be integrated easily. So that's the way, a form in which this works, the way it makes sense. I'll erase all of this extra stuff and write the formula. This you can derive this formula from this concept. Those of you interested, you can derive the formula that I'm going to write. Yes? Well, it's rho. We're going to use rho of x because that's what the textbook uses. Yeah, throughout. So the integrating factor, I was just focusing on fixing this part of the equation to work, but yeah, you multiply throughout. Where is it? So rho of x, you can derive this to be e to the integral of p of x dx. So you can actually sit and derive this formula from the concept that I gave you. So this is called integrating factor. So the way this works is going to be, you will have your dy dx plus, leave some space, p of x y equals, leave some space, q of x. You will multiply this rho of x everywhere. And once you have that, this part over here will be a product rule. which we can compress. So that will be the product rule right there. As everything in differential equations, these are procedures most of the time. Let's work on the example and figure things out. So how about dy dx minus 2xy equals e to the x squared? So this is problem number 4. Again, all of the exercises that are worked out in the textbook you can read because you know all the letters and numbers and just look at it. We do new examples, so you have more examples. The first order of business is to understand that this part over here is your p of x, and this over here is your q of x. You don't need q of x separated out, but that's what it is. Observe that the p of x, guys, the formula has plus, so your p of x is negative 2x. So make sure you are extracting correctly. So p of x is going to be negative 2x. We know that the integrating factor rho of x, I just gave you that formula. Those of you interested, derive it. E to the integral of p of x, which is negative 2x, dx, which is e to the, and now integral of this is going to be negative x squared. We're not going to use plus c in this situation because there will be a plus c once we are done with the differential equation. Okay? So we just need the antiderivative in this case. Yeah, for this calculation, yep. So now we learned that rho of x is e to the negative x squared. So what do? I multiply that throughout the differential equation. So I will have e to the negative x squared times dy dx minus 2x e negative x squared times y equal e negative x squared times e to the x squared. So I multiplied this integrating factor throughout, and now we are looking at the formula. So what are the pieces over here? I have u v prime plus v u prime. Well, in this case, it's u prime v. And I know that that collapses into uv everything prime. So u is going to be e to the negative x squared, and then y, all of that, right, in the derivative, equals to, this thing is just e to the 0, which is 1. So let's take a look. It's my pointer. All right. So once we calculated rho, which is the integrating factor, we took our differential equation as is, which is in black, and multiplied the red one through, which is our integrating factor. Now, once you have that, again, step away, and say, this is the function, everything in front is the derivative. So this is the derivative of that. So that's the function, that's the derivative. You also see that this is derivative. So this must be the function, this must be the derivative, this must be the derivative, and this is the function. In the product rule, you have two functions. So you pick the function from this side, and you pick the function from this side. That's what gets multiplied. And all of the derivatives, they get ignored because they're not in the product rule formula on the right-hand side here. It will take you some time to get used to it because you are using product rule backwards. For years now, right? Calc 1, Calc 2, Calc 3, your product rule was you start here and you write this out. Well, now you are condensing it. You're going backwards. So you have to recognize which part is the function, which part is the derivative. That's clear in this case. That's the derivative. The rest must be the function. And then on this part, again, that's the function that you're looking for. So the rest is the derivative. And you can visually check if this here, the whole thing, is the derivative of that. And it is because of the chain rule. The derivative of equal something is itself times the derivative of the exponent. But the derivative of the exponent is negative 2x. So there it is. It's awesome.
So in the end, is it always going to equal 1?
No, in this example, you know, they fixed the example so it does, but no. Now we need to integrate both sides to kill the derivative.
Okay.
Are we clear? Good. So now, what I'm going to do is integrate both sides, dx, and you see that derivative cancels the integral, leaving us with e negative x squared y equals x plus c on the right-hand side. Right? Integral of 1 is x, and then plus c. We are going to multiply both sides by e to the positive x squared. So y is equal to e to the x squared, x plus c in parentheses. And that's actually the general solution for this particular problem. We're done. We don't have initial condition to go further, so this is the general solution. Now, if you don't believe me, all you need to do is to take the derivative of that solution and plug in the original differential equation. See that everything cancels out. Should we do that once? Yeah, let's do it once. In green, check. So our differential equation was y prime minus 2xy equals e to the x squared. So I know that the whole y thing will plug in there, so that's good. I need y prime. So let's first figure out what y prime is. The function here, we have a product rule between the first function and the x plus c function. So copy the first one times derivative of the second one plus copy the second one, which is x plus c, times the derivative of the first, which is e to the x squared times 2x. So instead of y prime, I get to put e to the x squared plus 2x x plus c times e to the x squared. So that's all that. Minus 2x, and instead of y, I get to put e to the x squared x plus c equal, question mark, right, e to the x squared. Well, you quickly see that these two are identical, so they both die, and you have e to the x squared equal e to the x squared, confirming that this is correct, because equation checked out. we got e to the x squared equal e to the x squared. Anytime you do this check and they don't cancel out, you have obviously an issue, and then you have to figure out what's wrong. Always first check if you did the derivative right, to plug in, because if you did the problem right and you did a check wrong. Yes? Yes, you have to divide because, all right, guys, that was an excellent question. Again, these things for me are all intuitive, so I sometimes don't mention the obvious things. What you guys need to get used to is like the same thing what you did when you did sequences in series, right? The form in which the main equation is given is alpha and omega for that problem. So you are not allowed to have anything in front of dy dx, because if you're looking at this form, dy dx has nothing there. So if you have x here, you will have to divide through by x, and then you will have over x here, but that falls into this guy, and then will fall into that. So you're allowed to pick your p of x when this is completely isolated. That's how it has to look like. And then you go from there. And immediately to address this question, let's go with number 10 so that you guys can enjoy such a calculation. It says 2xy prime minus 3y equals 9x cubed. The next example we do will have initial condition. This one does not, so yeah. And that's what you're going to take the final as well. Yes, yes, normal class time. This is Tuesday, Thursday class. It's going to be Tuesday at 5. And you can have 3 or 4 Tuesday, Thursday classes. We'll have also the final Sunday at the time when the new class starts. So let's see which one you take. Three equations, all of those that are Tuesday will be here. So we are going to have 3 or 4 final. This year had bad timing to start the semester because of the so it is going to work. Right.
Official books. She needs the notes. She could just take on the phone. I write everything.
Yeah, it's a one-page summary of the definition field. Everyone is when you look at these, you will find so, you know, the time that you want to invest in I checked off that so it's a review and all that stuff. You will have to use section that we have in our text. It says 1.5. For the title, and if our linear equations are in this text of 1.5, text of 2.1, this is 1.5. So, you know, these concepts are the same. So, let's see. Only one person. We have 25 signed up for the class. So which is 490. So you were in class. You only had one today.
It ended up being
every class. You look at the syllabus, keep track of the syllabus, because I get behind with these things. Check out and then you know where so it's much easier. Before you get then before I
All right, so what is the first thing we have to do? Divide by 2x. So the first order of business is to divide 2x everywhere because our y prime needs to be alone. So we have, that's not dy, that's dy. So dy dx minus 3 over 2x, and then I'll say y on the side so we can see p of x clearly, equals to 9/2 x squared. So this is our transformed differential equation. We also see from here that x is not allowed to be 0 anymore because we just divided by x, right? So that's another observation that you need to be careful about. So we just kicked x out of, yes?
What did you say just before with the x not equal to 0? You got to beware of.
Well, we divided by x.
Yeah.
So x is no longer allowed to be 0 because we divided by it. Yep.
Oh,
All right, so now we are going to calculate our integrating factor rho of x as e, and then we have integral of negative 3 over 2x dx. Now, again, your skills in integration are important. We have dx over x, and that's going...
We have left 3/2 with y. I just pulled out the negative 1 over x.
No, y has to be alone for the purposes of the integrating factor because you need to, you will have the...
You put 3/2, 3 over 2x. Yeah. But could you have just left the 3/2 as a coefficient to the y?
No, everything, if you, again, we are going to look at the formula and realize that there is everything here and then just y, right? That's how we look at the formulas. So there is everything on a pile, right? Everything on a pile for px and just y stays behind. So technically, as you are looking at the formula here, trying to pick your p of x, you just erase the y, right? And the rest is px. And then you put the y back. That's technically what it is. All right, so the integral of dx over x is ln absolute x. Very good. We are not going to use plus c in this case, so we have negative 3/2 ln absolute x. Now, we have more stuff to do here. So we have e to the ln x raised to the negative 3/2. And then e and ln cancel, so integrating factor turns out to be x to the negative 3/2. Are we all agreeing on this? Now, what happened with the absolute value? Where, how, why did that vanish? Well, observe that you have exponent, in exponent you have over 2, right? And over 2 is operating only on positive numbers, right? So there's no need for absolute value because we understand that positive value of x are allowed in this case. We also know that 0 is not in the domain because of we divided by 0 earlier. Anyway, we have a rho of x, and we are going to go to our differential equation here and multiply this integrating factor throughout. So I'm just going to copy differential equation, leaving space to plug the function in. So I spaced stuff out, and now I'm going to go back with red and say x to the negative 3/2, x to the negative 3/2, x to the negative 3/2. And then I'm going to, I'm not going to simplify anything here. Please don't simplify, because once you do the integrating factor, it is in the form to push it together. If you simplify, you will not see it in some cases.
So in that line, do not
Do not simplify this, and then do simplify this piece. So, well, let's first deal with this. Again, I have the function, right? And since this is the derivative, this must be the function. We know that y alone is the function. It's always the case. On the other side, we know that everything but dy dx is a function. So you pick those two, and we have the derivative of x to the negative 3/2 times y, everything equal to whatever this works out. So that's 9/2 x squared times x to the negative 3/2, and you will combine these exponents to get. So again, you are picking functions because your fg prime plus g f prime is equal to fg prime. So as you can see, you pick the function from here, a function from here, and those are these two guys in the formula on this side. So that's how I pick these values. There are no calculations here. It's just you look at it, right? One more time, I pick the function from this. Y is always the function. On the other end, I want everything but this, because that's clearly the derivative. So that's how I pick these two values that go into the formula. Now, I have the derivative of x to the negative 3/2 y equals to 2 minus 3/2 is 1/2. So I have 9/2 square root of x is the thing. We are going to integrate both sides dx. On the left-hand side, the derivative kills the integral, and you are left with x to the negative 3/2 times y. On the right-hand side, you have your 9/2 coefficient copied, and the integral of root x is x to the 3/2 divided by 3/2. And then these numbers also cancel. That's what yeah, there is plus c. It's clearly, it's right here. See it? Thank you. So now 2 and 2 will cancel, 9 and 3 will cancel, give us 3 there. And we have x to the negative 3/2 y equals to 3x to the 3/2 plus c. We are going to multiply both sides by x to the 3/2, right? Because that will counter the negative 3/2, right? And then we'll get x to the 0, which is 1. So we only have y on the left. And on the right, as you distribute this, it becomes 3x to the, when you add these guys, you get a cube. All right? No. Yeah. You get 6/6. So that's 3. Plus c times x to the 3/2. And this is your general solution. We did not get initial condition. We did not get initial condition to calculate c. Again, take the derivative, plug everything in original equation, make sure it works, which is the reason why on the first exam you can literally go and say 100, right? Without me taking it home and reading through it, because if you check each one and they check out, right, that's the answer. This one?
Yeah.
Well, you can either say divide both sides by this, or I multiply by the opposite, right, to eliminate.
Okay.
Whatever you like, right?
So those cancel out.
Yeah, they cancel out, just giving you this, and then on the other side it multiplies through. Right. have 4 minutes. Should we squeeze another example? What else are you gonna do? Why go home? Everyone knows you there. Just let's. Oh, we have 1 minute left. And now it's even bigger resolve to stay and do another example. Or you can just walk out through that door. I mean, that's always an option. I mean, fireman right there, right? You can go use the window. Or Spider-Man. No more? You want to go home and do this thing at home or by yourself? Whatever. Guys, starting next class, so let me just say bye to millions that are watching. Bye, guys.